Hi and welcome. In this video I will show you how to run software on Rosco m68k. We will prepare SD card, connect through UART and run an example program.
Now let's take a look at the SD card. There are a couple of important requirements here. First, the maximum support capacity is 32 GB. And second, the card must be formatted using FAT32 file system. If your card is large than 32 GB, it might not work correctly with the system.
Let me show you how to properly format the SD card on Ubuntu. First, insert the SD card into your computer. Before we continue, make sure you don't have any important data on the card, because formatting will erase everything. Open the disk utility. On the left side, select your SD card, then open the menu and choose Format Disk. If you see an error like this, try to close all File Manager windows and try again. Then create partition, set FAT file system and set name. You can choose any name, it's not important for Rosco. Yes, mount. Process is complete. Your SD card is ready to use. Now we can move on and copy the required files onto the card. Alright, so we got our SD card formatted and ready to go. Now let's actually put some software on it. The way Rosco works is simple. When it boots, the bootloader looks for a specific file on the SD card called Rosco code 1bin. If it finds it, it loads and runs it. So all we need to do is take our compiled program, drop it onto the root of SD card and make sure it names exactly Rosco code 1bin. These example programs can be found in the official Rosco example programs GitHub repository. I will leave a direct link in the description below. So I am grabbing one of the precompiled examples, the memcheck program, copying it into the SD card and rename it to roscode1bin. And that's all there is to go. Card goes in, power on, and there it's running. Now a quick tip that makes this way more useful. You are not limited to just Rosco code 1bin on the card. You can throw a bunch of other bin files onto the root alongside it. The trick is what you put as Rosco code 1bin. There's a program called the SDFAT menu. If you flash that as your Rosco code 1bin, it's boot into a simple menu over UART where you can see all the other bin files on your card. Pick one and launch it without ever swapping files around or renaming anything. So the workflow becomes: put the file explorer as Rosco code 1bin, dump all your programs next to it, and you have basically got a program launcher pretty convenient for testing. Now let's look at how to load programs using Kermit over UART. By the way, all these comments and the config are in the description below, so you can just copy and paste everything. First, install the Kermit utility, open a terminal and run sudo apt update and sudo apt install C-Kermit. That's all, no extra setup needed after install. Next, we need to find which device your UART adapter is assigned to. Plug it in, then run you are looking for something like PuTTY USB 0. In most cases, it's going to be exactly that, so start there. Now, instead of typing all these connection settings every single time, let's create a config file. Create a new file called, for example, my device ckermit and paste this in. Two things to check here. Make sure set line match the device you found in the previous step. Most likely it's already PuTTY USB 0 and the baud rate is set to 38,400, which is what this board expects. And press Ctrl X, Y, Enter. And device created. To launch ckermit with this config, run ckermit and config name. Reboot Rosco, and that's all. And we see output from the Rosco board. Your program should start running automatically, or you can trigger it from the device side. To send a binary file to the device, you first need to escape back to the ckermit prompt. Press Ctrl backspace and then Ctrl C. You will drop back into the ckermit prompt. Now type send and path to your binary program. Copy file path. After the transfer finish, type connect to jump back into the terminal session. Now, let's do the same thing on Windows. And honestly, it's even simple here. The tool you want is PuTTY. If you don't have it yet, just search PuTTY download. The first result is free and it takes about 30 seconds to install. Open PuTTY and select serial as the connection type. Now you need COM port. Open Device Manager, expand ports, and look for your UART adapter there. As you can see on my machine, it shows up as USB serial. Yours might have a different name depending on the chip, but it will be listed there. If you're not sure which one is yours, just plug and unplug the adapter and see what appears or disappears. Enter that COM port on PuTTY. Set the baud rate 38,400 and hit open. Reboot Rosco, and that's it, you are connected. If you also want to transfer file on Windows, the same way we did on Linux, there's a ckermit client for Windows 2. It's called ckermit95. To get it, head over to the GitHub repository, go to the releases section, and download the archive from there. Once downloaded, extract it. You can extract it anywhere. I will just put it on the desktop to keep things simple. Inside the archive, you will find a bunch of files. What you are looking for is the file called K95G. Open it up, and you will get a terminal window with a ckermit prompt. Now we will enter the settings one by one. The commands are exactly the same as on Linux. Make sure to replace COM port, the one you found in Device Manager. For insert, right-click twice in a row. Once that's done, type connect to connect to the board. You should see output from your device. Reboot Rosco. To send a file, use the two blue arrows in the toolbar to switch back to the Kermit console. Once you are at the prompt, type send and path to your program bin file. After the transfer completes, hit the blue arrows again to switch back to the terminal session. To exit from program, press Ctrl+C and you can run next program. And that's everything. We covered 4 ways to get programs onto the board, from an SD card, over UART with Kermit on Ubuntu, and on Windows with both PuTTY and Kermit 95. Thanks for watching. If it's helped, leave a like and subscribe. More retro hardware content is coming. See you in the next one.